Alright, we're back. We are Game 2005 in the fall 2019 semester at George Brown. And we're actually going to be recording this one because we're talking about week 7. We're going to start programming some physics. So one thing I've done is please download the template from Blackboard. You should have access to this right now. It's template V6. This is the same template we used back in lesson 1 during our tutorial. Okay, so this is the one lesson I've recorded so far. I'm recording. The other lessons that are up on YouTube are from previous years, and it's all around the lecture stuff. But the tutorial is going to be totally different. One part of it is you're going to be submitting a GitHub repo for your physics programming part 1. It's lab 4, which is going to be due Friday. That's tomorrow by midnight. So GitHub link. So you need to put your stuff, you need to understand how to put your stuff up on GitHub. So this is good practice for how to do that. But the first thing we need to do is set up GitHub for the first time. So first, let me just close off the project that we're going to be creating. And I'm going to close off my applications. So one of the tests I want you guys to do now is go to your command prompt, and try typing in git ---- version. So if you type git ---- version, if it comes up with an unrecognized command, right, this is where we're going to have to correct it. So do you have an unrecognized command or a problem? Git ---- version. If you have something like 2.18. whatever or greater, we're going to be good. You don't have to worry about it. However, if you're using your own laptop, this may not be the case. So let's talk about the setup just in case you wanted to follow this for laptop users, okay? Or if you want to set this up at home. So why command line? Because command line gives us more information about what's happening behind the scenes. If you're used to using something like git kraken or source tree or something else, it kind of masks what's happening on the back end with GitHub, and we don't want that. We want you to understand what's happening. So we want this to work. So in order for us to get this to work, I put a link up on Blackboard. One of them is this git install link, and if I follow it, it takes me to git-scm.com, which is where you're going to download and install what you need for Windows. Let's do that. So if I click this link, it's going to download something I already have, by the way. So I've done this a couple times today, but let's just download it here. And then I'm going to launch this thing. Now, you need to follow these steps. So I'm recording it for this reason as well. All right, here we go. So first, you're going to get this little dialog box. If you're doing this for your own laptop, please follow these steps. Next. By the way, if you tried these steps for the machine in front of you, even if you had admin access, it would not work properly. Okay, so for example, if you have that username and password, if you're one of those people out there that have that, somehow, at least at Daniel's waterfront, it won't work properly if you try that. However, if you have a laptop, this is what you need to do. Notice that I've checked everything except for the last one. Next. I like to use Visual Studio Code as my default editor. I think it's a great editor. For more information about Visual Studio Code, you can certainly go to this link. I put this link up on Blackboard, right here. It's a great little editor. I'm not going to install it today. I already have it installed. By default, when you come to Git installation, you'll have it like Vim, right? Which is totally fine. You can leave it as a default. Right? But if you're like me and you like Visual Studio, then I select Visual Studio as my Git editor. And then I'm going to click Next. Next, you're going to choose Use Git and optional Unix tools from the command prompts. That's the one I want. The one on the bottom that says Warning. Okay? Next, I want to keep the Open SSL option on the top. Next. Check out Windows style, commit Unix style, leave that as is. Next. And then go with use Windows default console window instead of use min_tty. So I want to use this one. Next. I want to enable symbolic links as well. So all these should be enabled. And then click next. And then you don't want to enable experimental. One thing to make sure that this is going to work right is you definitely want command prompt closed before you click install. Right? Up until now, if you had command prompt open, make sure you shut it down. Then click install. And what this will do is it'll go through the installation process. If you've got a broken install, this will actually fix your install as well. And what this does is it will install Git for Windows. When you're done, it's going to take you to a screen that says launch Git Bash or view release notes. I don't want either one. I want to click finish. And now when you go back, you should be able to check your command prompt by going to the little Windows button on the left, pressing CMD and then typing git space -- version and then enter. And you should have this version, 2.23.0.windows.1. So why did I go do this? Because this is a great way of making sure that GitHub is working, and Git is working properly on the back end. And we may do some Git commands here to fix some of your problems later. We can shut this down for now. Oh, one more thing. Let me just go back to that window. Whenever you install Git for the first time, you also need to configure Git, and I recommend doing something like this. You want to set your username and your email address for Git, and the way to do that is type git config -- global user.name, and then in quotations your username as it will appear on your commits. So for example, mine would be Tom Tsuriopoulos. And then do the same thing with your email address. Now this email address is very important, as it's the email address that identifies you on GitHub. So you want to use the same email address that you've registered on GitHub. So again, git space config -- global user.email, and then in quotations whatever your email address was that you signed up on GitHub. I found this help very simply by just putting git space config username, and I googled it. Once you've done this and you've set up your global configuration, you're really good to go here. So again, I would just type in those things: git, config, and then -- global, and then user.name, and then in brackets whatever, or in quotations whatever your username is, and press enter. And I've already done this. And then same thing for user.email as it appears on GitHub, and then just enter. So if you do those two things, you're good to go. Now we can close this up. Next, so once you've downloaded our link for your template, which is right here, this is our template, you're going to get this link right here. In order for you to unzip it, I highly recommend 7-zip. I find that 7-zip in general gives you less problems than Windows decompression by default, right? So please download and install 7-zip now. Some of you will be using, by the way, if you're using the machine in front of you and it's from the school, you won't be able to do this. But this is for your own laptop. Once you've got 7-zip installed, or another unarchiver, if you will, then what you can do is you go to here and then click on the link once, right click. If I'm using 7-zip, I can just go 7-zip extract to template v6, and it's going to extract the little template that I gave you up online right here. I'm just going to rename this thing to session 3, which is you guys, and session 3 is the one that I'm going to be working with for this video. For you guys, you're just going to see something like this that you're going to be working with. Notice there's a couple things I've got. One, I can see the hidden.vs folder. And in general, when you want to see hidden files and folders, you can enable these in a couple of different ways. One, if you go to View, what I want to do is I want to go to Options, and I can say Change Folder and Search Options. It'll bring up this little window, and I can go to my View, Under View, I want to display file icons and file size information and full path in the title bar. I also want to show hidden files, folders, and drives. And I want to uncheck hide empty drives, hide extensions, hide folder, merge conflicts, and hide protected operating system files. I want to uncheck all those things. And then press Apply or OK. Once I've done that, I can see hidden files and folders. So if we initialize GitHub here in this folder, it'll create a hidden .git folder that you will not be able to see unless you did those steps. Alright, we don't need this right now. The only thing we need to do actually is just double click on our template.sln file. If we click onto it, I'm using Visual Studio 2017. You may be using 2019. That's totally fine. Both will work. Now there is a built-in Git extension that you can download from through the Tools, Extensions and Updates. If you're using Visual Studio 2019, there's going to be another menu item called Extensions, and you would click on Manage Extensions. Now I don't have that because I'm using Visual Studio 2017, but if you use 2019, you'll see another Extensions menu item. When I click Extensions and Updates or Manage Extensions, if I'm using 2019, I'm going to have this dialog box come up. What I want to do is click on Online on the left. And then I want to search for Git. Now this is really cool because this is a very valuable extension to have installed on your Visual Studio implementation, the deployment, right? It's going to say download. Like if I click on something else, it'll say download. It'll say this here. I've already done it. I've already downloaded the extension. So you click on download, and it'll run through the installation process and download it. And then it'll say on the bottom a little warning that says, we're not going to allow you to install this until you close and relaunch Visual Studio. So let's just do that. Close, and then we'll relaunch Visual Studio. I'm just going to close it down. It'll give you a chance to install it. I see some of you are doing it. If you're using the machine in front of you, it'll ask for an admin username and password, which you cannot provide. So just cancel that. However, if you're using the machine, your own personal laptop, you will be able to provide that. It will install the Visual Studio extension. And when it's done installing, you can press Finish. I'm just waiting for some people who are doing it right now. And then you can relaunch your Visual Studio project. I'm just going to wait till everyone's done. And now, when you did it, you should see this. Here's my Solution Explorer. My solution is not added to source control right now, and you can see that. See in the bottom right hand, it says Add to Source Control. You can also see that if you go to the solution itself, not the project, right-click and click Add Solution to Source Control. Please do that. Now, here's the challenge. If you've previously used something like Perforce, it'll give you an option to add it to Perforce or to Git. Please use Git, not Perforce. And then if Perforce, a little menu for Perforce comes up, just click Cancel. You don't want Perforce here, you want Git. Now that I've added it to source control, I want to push it online. If I have my online, my extension, I can go to Team Explorer right here on the bottom. Even if you don't, please go to Team Explorer. Let me show you this. Team Explorer is another window. If you don't have Team Explorer, you can go to View, Team Explorer. It gives you this window. If I click Sync, if you have the extension, you'll see this option right here, Publish to GitHub. If you don't have the extension, you'll see this option and this option, Azure DevOps and Push to Remote Repository. So I'm going to show you what it looks like to publish directly to GitHub. You click on this, Publish to GitHub, and what it'll allow you to do is it'll allow you to publish whatever the repo you want. Let's say, for example, on George Brown, I can make this repo name whatever I want. So GAME2005 in the fall 2019 semester, and it's lesson 7. I could do that. And then click Publish, and you're done. I could do that. Or if I don't want to do this, or if I don't have this, I could do this, publish Git repo, which is asking for a Git repo link. So let's do this one for now, because this is the harder one. So here I'm going to go up to my Git repository. So here it is. I'm going to make a new repository, new. And in my new repository, it's going to ask me for a name. I'm going to put it in, GAME2005 in the fall 2019 semester, and it's lesson 7. Not A, B, or C, just lesson 7. The other ones, A and B, I'm going to delete in a second. It also gives you other options for initialize this with a README file. Please make sure this is unchecked and don't add any git ignores or license files. Then click Create Repository or press Enter. It's going to give you this link as well as some instructions. All you need for Visual Studio is this link. Again, you will need this for your assignment too. It's one of the things you're going to be required to do with your partner. I'm going to copy this link. I'm going to go back to Visual Studio and paste it in here. And then once I pasted it, I'm going to click Publish. When I do that, Visual Studio does its job and publishes it to GitHub. And if I go back to my GitHub repo now and refresh, you should see that I have all my files from Visual Studio here on GitHub. So, example, this is a really cool thing for GitHub and Visual Studio is, A, I don't need another client. It's built in either way into Visual Studio. The Visual Studio GitHub extension, what it does is it allows you to publish. The built-in Visual Studio extension only allows you to publish if you have already created a repo. Those are the differences. Okay? But now that I have a connection between my repository online on GitHub with my Visual Studio project, I can literally just update it from here every time. One thing to note is what my folder looks like. Now, if you notice, I have a hidden .git folder that is being shown because of my options. Because of my folder options, I'm showing my .git folder. If you don't see this, it's because it's being hidden. Let's close this down for now. I'm also going to do one thing just from a housekeeping perspective. I'm going to delete repositories, these two repositories. Let me show you how that's done. When I delete a repository, I go into the repository, I go into the settings for the repository, and then go down into this danger area. And then it says delete repository. It's going to ask me for my password or the name of my repository, which is just this. And then it's gone after you put your password in. And I can do the same thing for my other one. This is my previous one from earlier today as well. So again, I'll do it again. Go in here, click on settings. If I want to delete something, I can go all the way down. And then I can just delete this repository. I can take the name of my repository here, copy paste it. And then it's going to ask me for my password if I haven't logged in. And I've already logged in, so it only asks me once. Now I have this lesson, which is what I'm going to be using for the remainder of today. Cool. So that's GitHub in a nutshell. Again, you'll be required to use Git or send me a link to your GitHub for this lab, Lab 4. You'll need a link to your GitHub. I will not accept a zip archive of your project files up on Blackboard. Just a link to your GitHub is what I'm looking for. Okay, for this particular project. All right, cool. So we've got this, and I want to continue creating my solution. So what do we have last time? So last time in lesson 1, if I run this little project, I have something that looks like this. It gives me a little ship. First it'll build and run. By the way, if you have a problem building and running, you may need to retarget your solution for your Windows machine. So you right click on solution, retarget solution, and then you should be able to run the project, no problem. But it should give you something that looks like this, a little ship. Alright, so that's what we did lesson 1. We just wanted to kind of push something out. So again, if you're having a problem, right click, retarget solution. and then choose the SDK that you've installed and press OK. That should fix your problem. Also make sure you're in debug x86 configuration, because if you're in any other configuration, I haven't set it up for that. And it should just run your project. Great. So what I want to do is I want to install something called an immediate mode UI. If I was to look and see what that is, if you search up immediate mode GUI, right? Really what they talk about is where event processing, like it says here, is directly controlled by the user, right? So instead of having an observer pattern and using an event listener, an event handler, all that kind of stuff, you can avoid doing that altogether by using an immediate mode UI. Now, luckily, I've installed something called Dear IM GUI, which is a very popular immediate mode UI. Typically, Dear IM GUI only works with OpenGL, right? There is, however, a small extension that I've included for Dear IM GUI for SDL. And what this does, by the way, is it creates these little menus. And these little menus that come up, it allows you to use labels and buttons inside of your application, so that way we can adjust physics settings on the fly, as opposed to waiting for us to rebuild and compile and build and compile and all those kind of things. We don't want to be able to do that. We want to be able to do things on the fly like this. So we're using an immediate mode UI called IM GUI. Let's set that up. So, how do we do that? One thing is, I've already done the heavy lifting, and I've got IM GUI and IM GUI SDL, which is that little port that I was talking about for SDL, installed and configured in your project. The only thing you need to do is make sure it works. Now, I already have an example of this from last semester. So if I double click on game.cpp, you can see that, by the way, if you look at the scope, global scope is what I'm looking at. Let's look at the game. And then let's go to Start. Under Start, you're going to see that by default, I'm starting with the start scene. However, I have an example of my in play scene, right? I have an example of my immediate mode UI running. Let's try this out instead. So I'm changing it from start scene to play scene, and then pressing play. When I do this, I get this, which is my immediate mode UI that comes up. Now, I don't want all this other stuff. This is from last semester. What I want instead is I want this little window for physics. So I want to port over or move some of the same stuff I've got for this window over to my start scene. Let's go back and put this back to start scene. Alright, so in order for me to move things over, there's a couple things I need to do. One, let's bring up my playscene.h. So this is where I've configured some stuff for IM GUI. As well as, let's bring up my startscene.h. So again, under Solution Explorer, startscene.h. What I want to do is I want to show these side by side. So I'm going to take my startscene.h and pull it over down here, so I can show both things side by side. Play scene on this side, start scene on this side. I want to scroll down, and I want to get to, on the play scene, right here on line 89. From line 89 to line 99, I want to copy all this stuff in the .h, and I want to paste it in the private area of the start scene.h underneath the ship definition. Now what this does is it sets me up nicely for my UI, but I'm missing a few critical functions. And I need to take those functions as well as update my handle events function from my play scene into my start scene. Now again, guys, this is a very long way of doing it, and I could have created a superclass that has all this stuff. I could have created an input handler, and I could even have created a IM GUI class wrapper that does everything for me. But we want to make this simple, so we're just going to copy paste. So here I'm going to save, and I'm going to shut these down now. I don't need these right now. I'm going to pull up the next two. So now the next one I'm going to pull up is startScene.cpp and my playScene.cpp. Again, going back to Solution Explorer, playScene.cpp. I want to take my start scene and I'm going to pull it to the side again so it's side by side. By the way, CJ, since you came in late, I'm recording this. I'll put this up on Blackboard later so you can always follow the steps. And by the way, if anyone here, if I'm going too fast, you can always follow the steps on Blackboard later on, right? From the video that I'm going to post, which I'm recording right now, that you can follow later on so you can submit everything you need for tomorrow's Lab 4. Okay? Alright, so let's look at this left. So this is play and this is start. I need to copy stuff from here to here. First thing, let's change our global scope here to play scene. Let's change our global scope here to start scene. And then what I can do is I can go into the first parts. The first thing I want to change is my draw. Let's go to draw function. So draw function shows a couple things that are different than the draw function on the start scene. Here's my draw on the start scene. I don't need these two lines anymore. I've commented on that anyway. Let's just get rid of it. Here on the draw scene, I do need this stuff. On line 777 of the playScene.cpp, I want to take these lines here, copy them, and put them underneath the m_p shift draw function call right here. So that's the first thing. And what these lines do is it starts rendering the user interface, the IM GUI, if my display is set to on. That's what this does. That's number one. Second, I want to change my update function. So go down to update. Here's my update function. And I'll do the same thing. My update function. Notice my update function is pretty blank on this side, but here what I'm looking for is on line 797 of the playScene.cpp, I want to grab these lines here that displays and updates my UI and copy them into my start scene. Cool. Those are good. Next, I'm missing all of those functions that I defined in my .h file. So I'm going to go to the first one, which is, and again, if you scroll through, you see them. IM GUI key map. I want to get that first, so go there. And again, here I don't have an IM GUI key map. What I'm going to do is I'm going to copy where it says IM GUI functions. I'm going to minify or collapse these three functions that are under IM GUI functions. That's from lines 403 to lines 479 on your playScene.cpp. I want to copy all of these. Notice I went just below the last one. Copy them. And I want to go all the way to the bottom of this one on startScene.cpp and paste them in. One thing I need to do though, and I'm just going to minify them again, is I need to change this. It's not play scene, but rather start scene that I need to change for all of these. So I'm just going to go here and just change their signatures for the namespace that I'm using. Okay, so start scene, IM GUI map. Now I'm going to get all these errors, and I'm not worried about the errors yet. You can see they pop up because there's certain things that I've copied over that don't make any sense for the start scene yet. So just ignore them for now. Okay, one more thing I need to do. I need to go to my handle events function on the left. So I'm going to go here to my handle events function. Again, I'm going to go to my play scene scope, go to my handle events function. There it is. And here I want to do the start scene scope and go to my handle events function. I want to wipe out everything on this function here. In fact, I could literally just wipe this function out here like this. Let's just do it. It might be the best way to do it. So just delete it. And I want to copy this one, this version, across. One thing I need to do, just like I did for the other one, is change this from play scene to start scene. Now I don't need playScene.cpp anymore at this point. I've copied everything over and I can close this off. However, I got a pile of errors, and we're going to go through and fix them right now. Let's go through some of them. So what does this do? So here on line 51 of my start scene now, I'm going to have, and this is where I put the handle events function. You could have put it somewhere else. I need IAMGUI. I'm setting up IO for IAMGUI. It's going to have a separate input output than SDL. Okay. I'm setting up my mouse wheel as well as other things. And if I scroll down, you can see that I'm pulling events from SDL. I'm pulling for mouse motion. For quitting the game, if I press the X on the window, it'll quit the game. Mouse wheel motion, it'll capture. And any kind of text input, it'll capture that. Then I have a bunch of key downs. So when I press the escape key, using SDL, I quit the game as well. So I can quit the game by pressing the X on the window or the escape key. Here's what I don't need. I want you to delete case SDLK1 and case SDLK2. Those are the 1 and 2 keys. I'm not going to move from one scene to the other, so I can remove those. Next, the SDLK back quote. That's actually the backtick character on, which is next to the, underneath the tilde character, or next to the 1 key, or above the tab key. I don't know, however you want to see it. That's what this back quote is. So whenever I press that backtick character, it's going to turn off my UI. So I can't see my UI anymore. That's what it's going to do, because sometimes I don't want to see it. Next, I want to get rid of the F, the G, the M, the P, and the R keys. I don't care about those. Let's just get rid of those. Again, it's easier to destroy than to build. Which is going to take us down to this WASD section. I want this section, but I don't want anything in here for now. So let's just wipe this stuff out. So kill it, and then we're just going to kill these values, leave them blank for now. So they're placeholders for us to use when I want to move things around in the game world later on. I also want to delete, I want to skip this section, I want to delete some of the key up values as well. So anything in the key up values, delete those too. Again, I'm just going to delete those values so that I have those WASD keys for both key up and key down deleted. That's it for your event handler. So now your handle events function is clean. We're good to go. We have no errors there anymore. If you still have errors, you missed something. Again, just to review, all I went into the handle events function, and I took some of these events out that were causing me a little bit of an issue. I've also removed SDLK1 and 2 because I'm not moving from one scene to the other. And then I took away all the key up and key down functions. Okay, now the next part. The next part is actually a little trickier. And to explain this, the update UI function, what it does is it creates something called a new frame, which makes a new window. And then what it does is it uses a window string for the title bar. Right now it's just using settings. Let's call this physics settings. Take away these spaces. I don't need these spaces anymore. So physics settings, that's the name or the string that's going to be associated with my title bar. And then I set up a few flags. IAMGUI window flags always auto resize, which means my window's always going to be changing size the more controls I have to accommodate the controls. Next is IAMGUI Windows flags no move, which means I'm not allowing the window to move at all. If you take this off, you can move the window around. As well as I want a menu bar to appear. If I don't have this, no menu bar. And then I'm setting the initial Windows position, and every frame I'm making sure that it's locked to 0, 0. That's what's happening. Remember, the immediate mode UI happens, it updates and redraws itself every single frame. That's what's happening here. Then I have my menu. I have a menu. The way IAMGUI works is it has the following things. It says, hey, IAMGUI, start a menu bar. Cool. If everything's successful, return true. And then I say, well, if we're good, if we have a menu, then do something. So in the menu, if I have a menu, then I start off different menus for each option. File, help, edit, whatever you have normally up on top of you can set up here. That's what this is doing. IAM-GUI separator adds a separator to the menu. IAM-GUI menu item adds another menu item and an action that you can imply here. And then finally, for after the menu item is complete, you can have multiple menu items. After this whole menu is complete, you have to put end menu, which basically pops the menu off the stack and allows you to go to the next thing. So again, kind of wordy, but what it's doing is it's saying, hey, begin here and end here, and then add your menu items in the middle. Now, if you wanted a complete documentation for all of IAM-GUI, it's available to you. But first, let's do this. We have a bunch of errors. Let's go down here and comment out all the errors, all the way to the bottom. So after this like little line, which is around line 295, which is a little comment line, comment out everything until the bottom. Make sure you don't comment out the bottom one though, and I'll show you that one. So I scroll all the way to the bottom. Damn. Let's try that again. I meant to go from here to the bottom, but don't include the IAM-GUI end here, and then just comment it out. And now, no more errors. So again, I'm commenting out from this line, around line 295, all the way to the bottom, which is here. But I'm leaving IAM-GUI end in there. Otherwise, you'll get a weird error. Okay, cool. Going back to the top, there is an example UI that you can set up, and it's right here. Show demo window. That's on line 250 around. If you enable that, you can see that this is the demo window that is used by IAM-GUI for teaching purposes. If you enable this and press play, show demo window, then what you get is something that looks like this one day when it starts. It's basically every kind of UI control you can possibly think of is right here. In fact, you can move the window around, and what it does is it gives you examples of every kind of widget or control you can possibly need. For example, I want some kind of different widgets. I want a combo box. What does that look like? Well, it looks like this. And then you can see what the implementation is going to look like for IAM-GUI. Drag and drop. How does drag and drop work? Right? Like this. Right? You can see how that functionality works. How does other functionality work? Well, it's all in here. Let me just get out of this for a second. So this is cool to look at. Well, how do I find the documentation? Well, there is no documentation. What IAM-GUI provides you with is a file. If I go to my Solution Explorer, under the IAM-GUI filter, which is right here, there's a file called IAM-GUI demo.cpp. And if I double click there, you can see that this file, and it warns you, it says, hey, if you're tempted to delete this file, don't do it, because this is a really cool file to have, because it shows you how to implement every single type of example. So here's my helper marker. I can go down and see what buttons look like, and toolbars, and all kinds of other stuff. It gives you examples of menus, what they look like, how to set it up, and the whole thing. This is where you look to see examples of how you could use different controls for your user interface. So please don't delete this. Look through this when you have a chance, and it'll show you in order that you saw your demo all the different kinds of controls. So if you want to learn how to do something, guys, there's an example right here. However, let's make that a little shorter. I know how to do some stuff. Let's make some stuff appear. One thing to note is that IAM-GUI has its own vector objects. We've been using GLM vectors, so from the GL math library, right? But here IAM-GUI has IAM-vec2s, which is a vector we can use later on. Keep that in mind. It has its own vector system. Okay, so here I'm saying, hey, begin a menu bar and so on. If I scroll further down, you can see that when I want to display the About menu, all I'm doing, by the way, is saying, hey, if I go to Help and if I go to About, change the display About menu from true to false, or from false to true. When I click on this, this toggles. That's what it does. When it toggles, or when it goes true, this activates. Remember, it's all in line because it's an immediate mode UI that updates every frame. All of these options are checked every single frame. Cool. So instead of about pathfinding simulator, we're going to say about physics. For your assignment 2, when you use this example, please put all the authors' names in here. Right now it's just me. You want to put your own name, and you want to put any other partner you have in here as well. Okay, for your assignment 2. Cool. Let's make this button work. So I'm going to uncomment this button. And again, we don't care about respawning any ships. What we care about is if gravity is on or off. Let's just say toggle gravity. Wait a minute. We don't even have any gravity yet. We don't have no gravity, acceleration. We have nothing. We're going to set up all that in a second. First of all, let's see if this button appears like this. So again, how this works is, hey, I am GUI. Make a button. Cool. Put this text in the button. Toggle gravity. Okay, good. When someone clicks on the button, then do this stuff. That's how it works. It's pretty simple. So if I run this thing now, you're going to see that all I have is toggle gravity. That's all. In my help, I have an about, and it says about physics, and it's me. That's what you should have right now. So my toggle gravity, what I want it to do is change gravity from true to false, and from false to true. But I don't have any gravity yet. We have to set that up. Let's do it now. So this is the second part of my setup. So part 1, I set up I am GUI. Hey, guys, this is a great place to put it up on GitHub. Whenever you make a feature, put it up on GitHub as a commit. I'm going to do that now. I'm going to go to my Solution Explorer. I'm going to click on my Team Explorer. I'm going to go to Changes. These are the changes that I've made, right? Start scene CPP, start scene.h. Hey, I even changed my IamGUI.ini when I ran this thing. So, if that's true, what I want to do is, I'm going to say configured IamGUI for start scene, which is what I do. I'm going to commit all. That's my local commit. And then I'm going to go home, sync, and push. And what this is going to do is going to push my commit online to my GitHub remote GitHub repository. And let's just check that. So I'm going to go to my repository. I'm going to go to lesson 7, and you can see now that I have 2 commits. And one of them is configured IamGUI for start scene. So I did this all in Visual Studio. And it tells you when I did it. Cool. Now that I've got that done and my UI has been configured, let's add some physics variables. In order for me to do that, I'm going to go back to my Solution Explorer. And I'm going to go to my startscene.h file. Here's my startscene.h file. If I scroll down, I have some variables for IamGUI, but I want some variables now for physics. So I'm going to add some in the private section. So again, these are physics variables. We're going to change these this semester a couple of times. The first variable that I like is, hey, is gravity on? It's a Boolean. I'm going to call it m_is gravity enabled. I'm going to set that to false by default. Okay, so gravity is not enabled. Next, let's set up gravity. It's going to be a floating point number, m_gravity. I'm going to set it to a default of 9.8 meters per second. However, one thing to note, we don't have meters. We have pixels. We need to make a conversion from pixels to meters. And so we need a scale. My recommendation is we create a scale. We're going to use a float for this one, even though it doesn't make sense. m_pixels per meter, which we're going to say for now, we're going to start off with a 10.0. So this is pixels per meter scale. And why are we doing this? Because we want to take our screen and map how many pixels it takes to make 1 meter. Because remember, physics uses meters and kilograms, right? And we don't have meters, we have pixels. So those 3 things we want to set up first. Next, I want to set up a global velocity, a global acceleration, and a global position for now. Later on, we'll update our own objects to have all those things. But for now, we're going to have it so that it's here, so we can control it. So I'm going to say that velocity is or position is a GLM vec2 object, right? Which we're going to call m underscore position. By the way, you may want to call this final position because that's what it's going to be, the final position every frame. And we're going to initialize that to a GLM vec2 object, an empty vec2 object that is going to be initialized to 0.0 and 0.0. Remember that each of these position, velocity, and acceleration, they're all going to be vector type objects. Next, let's copy paste this and make velocity and acceleration. So my m underscore velocity is going to be 0 for now, and my m underscore acceleration is also going to be 0. And again, I'm using the GLM library to give me vector 2's. Are we good? So again, some of these physics variables are the ones I'm adding in right now. However, we're going to have a problem. Our time is in frames, right? I'm operating at around 60 frames per second. Well, if I was to run the simulation with frames, it would be like super fast. That means we'd run through 60 seconds of simulation every frame. It's way too fast for our physics. We need to slow this down. We need to scale it down, which means we need a time factor to slow it down. If we know that I'm running 60 frames per second, if I take 1 divided by 60, I'm going to have a reference to how fast I'm going to be moving every frame. I can scale it down so that each frame is a lot slower. It's like 1 second, as opposed to, you know, the way it is right now, which is like 60 times as fast as you want to run. So I want to go and do a float, which we're going to call m underscore time, my time factor. And I'm going to say that this is going to start off, and again, I could put 1 divided by 60. I could do that, but I'm just going to put a value, 0.0166667, let's just say, f, which gives me approximately 16 milliseconds. So I'm dividing by the time sync that I'm using every single frame, right? This is going to cause a problem because if I was to multiply this or by itself, so if I do it to the power, it's going to get smaller and smaller, which means this is not going to work how we want it to. So I need one more time value, and I had a good suggestion earlier. I'm going to use something called m underscore acceleration time, which is also going to be 0.016667. So this is accumulated time. And we're adding 16.666 seconds. We're going to do this again as well. And you're going to see how this works in a second. Again, there's other ways of doing the same things. Some people use delta time, right? But that could be an issue. Delta time basically talks about how long it takes between ticks, between frames. And they take that frame time and they accumulate here and add it to acceleration, right? Alright, so we got some values. Let's go back to my start scene and start thinking about this then. Okay, so I want to toggle gravity on and off. So how does the toggle work? I'm going to say that is m underscore is gravity enabled is going to be, well, let's check it if it's already enabled. If it's already enabled, then make it false. Otherwise, make it true. This is using the ternary operator that's built into most modern C-influenced languages. Okay? That's like saying if gravity enabled is true, then make it false. Else, make it true. It's all in one line instead of 9 lines that you'd have, or whatever it would be. Or at least 6 lines. Does it make sense? Alright, so this toggles gravity on and off. Now what I want to do is I also want to set up my gravity scale. So right now my gravity is set to 9.8. Might be too small. I'm going to scroll down here and get an example of a floating point slider. Here it is. I'm going to grab everything from, including push item width. I'm going to grab all this, copy it, and move it up underneath my button. And then I'm going to uncomment it. I don't need the stuff inside. That's garbage. And I don't need this. I'm going to call this gravity. I already have a gravity set up. And I'm going to replace this line here, this part right here, with a reference to m_gravity. I'm going to say that gravity can go from 0.1 to 30 with a scale factor of 0.1. So small increments. I'm not going to put anything in here right now. That's gravity. Let's do the same thing, right? I want to do the same thing for a couple of other sliders. I want to make a slider for ppm, which is pixels per meter, right? Which means that my pixels per meter is also going to be something I can modify. I can change my scale. So again, it's not going to go from 0.1 because pixels can't be 0.1, but I want to make it go from 0.1 or 1, which is really small. So 1.0 is the minimum, to 30. If that makes sense to you. Okay, that's pixels per meter. So gravity, pixels per meter, and what else do I need? I'm also going to use time scale. I want my time scale to change too. I want to be able to control that. So, because remember, I don't know if my time scale is too fast or too slow. I have no idea. So let's do that too. So again, I'm going to go down here and put that in. I'm going to change my time scale. So time scale, or we'll call this time factor. My time factor is going to be m_time. And this is really big actually now. So it's going to go from 0 dot something really small right? So 0, 1, 6, 6, 6, 7 to something a lot bigger, which is like not too much bigger though, by the way. 0.2. That's pretty huge. So I can really speed up or slow things down. And I also want to change my accumulation factor. So I want to call this, we'll call this accumulation. Well, maybe time accumulation. Time accumulation. Again, I want to have the same time scale as this. Alright, so what the heck am I getting now? Well, if you think about this, if I run this code, I'm going to get a few sliders and a button. Let's see how it looks. Are you with me? So here's my gravity, my ppm, pixels per meter. If you really don't like pixels per meter, you can always just write in pixels per meter. That's perfectly fine. Time factor and time accumulation, which we really shouldn't do anything with, because it looks like it's 0, but they're really not. They're very small values, right? So again, if I really want to play with these, Notice that I can't, and they both work together because I messed up. Here it's M time, and here there should be M A time. Pretty small, right? And by the way, if you really want to, you could go down here and change the scale. So you can say something like this is 0.001, so smaller scale. And you can see that there's no difference. It's pretty small, but I can scale it up quite a bit. And it goes like from 0 to 0.1 to 0.2. Guys, this is not going to help me at all. 0.1 is huge, right? So I wanted to show you what the scaling looks like, so we can probably take these away. Here though, let's call this pixels per meter, because it's more descriptive. Pixels per meter. And now we're left with something that's reasonable. Gravity and world scale, right? Cool. Again, if I go to the file, I can exit here, or I can press escape, or I can press the X. So we've got some factors that we want to play with, but how do I move my ship around? By default, my ship is in the middle of the screen. What I want to do is I want to apply gravity on it. Okay, so how do I do that? I need another function. So go back to my start scene.h. If I scroll down, here are my physics variables. I'm going to make another one. These are going to be called physics functions. For now, I'm just going to call it move. We're going to change that later. So a move function. What I want to do is I want to use my little light bulb to create a new definition for it. There it is. And then inside my start scene.cpp, I want to go to my move function. It's going to be empty. So a couple things I want to do. I want to implement the move that says this: final position is equal to initial position plus initial velocity times time plus 1/2 acceleration times time squared. So that's that physics function that we saw before in our notes, right? Which is, you know, P naught, right? Or P final is equal to P initial, right? Plus V initial times T, right? Plus 1/2 of A T squared. That's what that is, right? I want to do this every frame. And I want to add the final position, this final position, onto my ship's position. I want to change this. This is going to be my ship's position every frame. So in order for me to do that, I need to set up this. I'm going to say that M underscore final position is equal to the initial position, which is the ship's position, which is M underscore P ship, and then get position. The ship itself has a position. We're just getting it because the ship is a game object. Plus the velocity times time. Well, my velocity right now is 0, but let's just add it in. I'll say that velocity multiplied by a scalar M underscore time, right? Plus, I want to multiply my acceleration, right? Whatever that is, M underscore acceleration. I want to multiply that whole thing, right, by time times time, or time squared. So I'm going to say something like M underscore time multiplied by M underscore time. That's what I want to do. And it's a neat idea, but it's not going to work. Can anyone see what the problem might be for this? Yeah. Actually the opposite. So the answer was it might go too fast. But actually, if you think about what I'm doing, look what I'm doing. I'm saying my time is equal to 0.1667, whatever. If I take this and multiply it by itself, it's going to get smaller and smaller and smaller. So in fact, acceleration will actually go down, not up. That's bad. I don't want that to happen. So we need a factor for this. And what we want to do is every frame, I want to add acceleration time to it, or accumulated time. So I want to say that my accumulated time is what I want to add here. Instead of adding here, this is the only time I need it. Instead of adding time, I want to add A time. My A time starts off at the same as M time. But what I want to do is I want to say that M underscore A time, every frame, plus equals to M underscore time, which is going to take the initial time value and add its A time every frame, which means it's going to get faster and faster and faster. 2, 3, 4, 5, 6 seconds. Just like a normal seconds would go, right? You go 1, and then you add 1 to it, 2, and then you add 1 to it, 3, and you add 1 to it, 4. That's how normal seconds would go, right? So this way we're adding slices of seconds every frame, so that way the acceleration will make sense. Otherwise it won't. Cool, so this is going to work, but I need to plug in the proper values for velocity and acceleration. Right now the acceleration is 0, so I'm not going to move anywhere. So I got to say something like this. So M underscore velocity, really what I want to do is I want to set up my velocity different later, but for now what I want to say, well, that's equal to a new GLM vec2 object, and it's going to be 0.0f and 0.0f. For now, let's leave it like this. Acceleration is also going to be the same. Oh, by the way, this is this. However, I also want to multiply it by M underscore ppm. Why? Why do I want to do this? How come? Why is this the case? And why is this giving me an error? Should it give me an error? So this is a new, this velocity is a new vector, right? And I'm multiplying it by this. I could also say velocity is equal to velocity times this, but the next one is the same. So I want to take the same thing for acceleration. Instead of velocity being this, I'm going to say that M underscore acceleration is equal to this, but guess what's going to go here? Gravity. M underscore gravity. I'm multiplying it by ppm because it's in meters, not in pixels. This would give me the velocity in pixels. I don't want pixels, I want meters. So I'm multiplying it by my pixel factor, or my scale. So this is gravity, and right now the acceleration is 0. It's like I'm dropping a stone. That's what this is. Cool? So this figures out what my time step is going to be, my final position, every frame. Every frame, this is going to be changed, right? Because it's going to get the new position for my ship. But then I got to update the position of my ship, which I'm going to do here. I'm going to say that M underscore P ship set position to the new position, M under final position. So my final position every frame is going to be the new position of my ship, which means my ship is going to move according to my physics function every single frame. And just to make this nice, because this might bother you, you can see that this is one term, this is the second term, right, and this is the first term. So first, second, and third terms of my little equation. P naught T, P final is equal to P naught T plus V naught T P naught plus V naught T plus 1/2 AT squared. Okay? So that is my function. I have to call this every frame. So I'm going to go back up to my update function. And in my update function, I'll say, okay, cool, with the UI, show the UI, but what about this? I want to only turn this on, I want to say, if gravity takes effect, right, for now. If M underscore is gravity enabled, only then do I want to M underscore move. Are you ready? Let's try this out and see if anything works of all the stuff we tried to put in place. So recap, we did this. In my start scene, .h, we enabled some physics variables. We kind of thought about what my gravity is going to look like. We thought about what's my scale. We thought about the final position of the object. We set that up. Velocity and acceleration, we set those things up. We also set up a time factor for both the object moving down and the object moving with acceleration. And then we set up a physics function to move everything according to our general physics function for parabolic movement. Now, notice things that are missing. We don't have an angle. If we wanted to have an angle, for example, the angle of attack, if I was going to send something kicking up, which is one of the first types of motion we want, we would have to use cosine and sine. We're not doing that here. We're just trying to make it so that there is no angle. It's Galileo's experiment when we're just dropping a stone or firing a cannon straight. That's what we're doing here. Let's try this out. So how does this work? Does it work? So if I enable gravity, then we should see a drop, right? And that makes sense, doesn't it? Because it's going to start accelerating faster and faster and faster as it goes. Now, if you think that this factor is too much, it's going too fast, let's try other values with IMGUI. IMGUI allows me to change my values. Let's go with pixels per meter. I'm going to say that it takes 30 pixels per meter. What happens then? Does it change anything? So toggle gravity, same speed if not faster. You know what I would like also? I'd want a reset. I want a reset button so that I don't have to keep on doing this over and over again. Let's add a reset button in there. So I'm going to go back to here. Again, I'm going to go to my IMGUI update, and down where we have our first buttons, here's our GUI, our update. I want a button in the same place, and I'm going to use same line for this. IMGUI same line, which is going to put it on the same line as my other button. Copy the button, and instead of toggle gravity, I'm going to make this button called reset. Reset all. So what is reset all going to do? My gravity is going to be not enabled. My ship's position is going to be reset. Right? So M underscore P ship. Right? Set position. Set position. To a new GLM vec2 object, which is going to be like, I think it's 800 by 600, so that's like 400 by 300, which is where it starts off. That's the initial position for my ship. How about anything else? How about gravity? How about all that stuff? Well, I got to set that back up too. So I'm going to say that M underscore gravity is going to be equal to 9.8 F. And M underscore ppm is going to be equal to 10.0 F. So there's a reset for you. Okay? And if I press play, I can change different things. So far, not a lot. But we have this. So I can change the gravity factor. Let's say let's change the gravity factor back really low. So I'm going to change to like I don't know, 0.1. And then toggle gravity. You can see that it works pretty good. It's just, you can see it more. And I want to reset everything and reset back to normal, right? And then now I can change my pixels per meter. Let's make it really small, like 1 pixel per meter. And then toggle gravity. And you can see it's gone, right? It's like super fast. So that's wrong, right? We know that's wrong. Reset. Let's make it the other way around, 30. And then make gravity even small as well and see what happens there. And it's also gone. Something's going on here with this thing, right? Reset all. So I know what's happening. We reset some things, but we didn't reset the other stuff. What did we not reset? A time. A time also needs to be reset, guys. So M underscore A time, that's going to be equal to 0.016667 F. It's going to reset. We need to do this, otherwise it's going to not work. Let's try it again. This reset all function is actually critical because otherwise we'd have to relaunch this program every single time. Let's try it again. So again, I want to go with, instead of 9.8, I want to reduce it to 2.4 and click it on. Okay, good. Reset. I want to try a different factor. So I want to go with a much larger frames. And toggle gravity. Okay, pretty cool. And I want to go with smaller frames and toggle gravity. And that's okay too. And that's pixels per meter. And reset all. And I want to change my gravity scale to lots, like 30. And toggle gravity. And it'll go faster. Reset all. And so on. And you can see where I'm going with this. I can keep trying different values until it makes more sense for me. Okay, cool. We got some of these things, but what I did was in my move function, I hard-coded some stuff. I said that my velocity is 0.0, I don't want this. I want velocity across the x-axis and velocity across the y-axis. I want those two things in here. And in order for me to do that, I want those numbers to be something I can modify, right? I don't really care about acceleration across the x-axis because mostly acceleration is just going to be gravity anyway, right, for now. But let's see if I can change my velocity across the x and the y. And the other thing I don't have is my kicking angle. I don't have that. I need to kind of modify this equation so it's a general equation, that it'll work for any angle, that it'll work for any velocity, any gravity, any scale, right? So let's do this. Now there's still some stuff we need to optimize. So how does this equation look? Well, we know that P final is equal to P initial. That's cool. Plus, we want to break out across different axes. So P final across the x-axis is equal to P initial across the x-axis plus V initial across the x-axis times cos of theta. I don't have a theta, but we'll just put like cos of theta times time, right, plus 1/2 of A across the x-axis squared. So you want this. And I want the same thing for the y-axis, right? That's what we really want. Does that make sense? We want cosine and sine, right? And we want a kicking angle. We want this theta, whatever that theta is, right? In fact, we could just write that in. Cos of theta, right? Times t. All right, that's the equation we really want. We're actually combining it here into one equation, and we're using vectors, which is great. but I need different factors for these. So I need an angle. I need to modify my angle. And also remember, whenever we use cos and sine with computers, we need radians, which means we need a deg to rad conversion, right? So again, if I was going to get a deg to rad conversion, degrees to radians, my degrees to radians is 1 degree is equal to 0.77. How do you convert from degrees to radians? Well, we just take that and multiply by pi divided by 180. Pi divided by 180. Wow, what is that? So if I take calculator and I go pi divided by 180, I get this. Do I always want to calculate pi divided by 180? No. We want a number like this. I want to multiply by pi divided by 180 every single time, right? And that'll give me radians. This is how many radians I got. So I want to take this number, and it's pretty big. I want to take it down to many decimal places. Let's say something like this, right? So that's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And, because that's what it is, it's multiplied by pi divided by 180. Okay, cool. So I want to take this and go into my code, and in my start scene.h, a couple of things I can do. I can make a constant, so I can make a const, which is a float, which will be just deg to rad, right? And that equals to this. Does that make sense? So now, whenever I want to convert from degrees to radians, I multiply it by go to this. What about if I want to convert from radians to degrees? Maybe I'll have to do that at one point. I want something like that as well. I want another constant, float, rad to deg, radians to degrees, and I want to convert that as well. So again, if I go from radians to degrees, radians to degrees, you can see that. How do I convert from radians to degrees? The key is knowing that 180 degrees, multiply the measurement in radians by 180 divided by pi. So it's the other way around. So I take pi 180 divided by pi, and that gives me 57.29. I want to get the same level of detail. 1, 2, 3, 4, 5, 6. Up to there. That's pretty accurate. And I want to say that that is my factor. Questions around this. So I have two constants. And why would I want constants instead of calculations? Guys, if I have to convert every frame, I'm doing division every frame, that's crazy. I never want to do division every frame, or multiplication, if I can avoid it. I wanted to have one factor that I multiply over and over again. So that's deg to rad and rad to deg. Cool. So I got these things. Also, who knows how to do cosine and sine with C++? You guys learn how to do that? The answer is no. Well, we know in JavaScript, guys, in JavaScript, there's math functions. It'd be something like this. Math dot and then cosine. Math dot and then whatever, right? So remember, we want to do cosine and sine, and again, type it in. Sine in C++. If you looked it up, right, you use a standard library for math. Again, it says CMath is what we want to use. Here's the header, CMath, and we want to multiply sine x, where x is in radians, if I'm not wrong. Radians. Okay? So CMath is what we want. Let's go back up. So here in the top, we want to include C math. I mean, what we want is whenever I do something like, you know, cosine, I should just be able to go cosine now, or A10. A10-2 is what I want to get for everything else. Now notice there's A10-2 and there's A10-2F. Guys, we want to use the floating point number, not the A10-2, unless you want super high falutin calculations, right? So again, it would be cos F, which is the floating point function, as opposed to cos, which will give us a double. Then we can avoid translations. We can avoid, you know, conversions for our math that we need. Okay? So now we have those factors. Cool. Next, I want to be able to convert this function to have an angle. So I need a kicking angle, which I'm going to put in degrees. So we're going to say that float m underscore angle is equal to 0.0f for now. So this is the kicking angle, we'll say. Or if you want to also look at this as the angle of attack. That's what this is. Right? So now that we have this, we can control this in IMGUI. Right? And I want to go from something like 0 to 360 degrees, but that doesn't make any sense because 360 degrees would be like backwards. So maybe 0, right? 0 to like 180 max, where 0 is, you know, 0, 1 degree is 1, 2, 3, 4, 5, all the way behind you. If you even want to think about it, you may want to go from 0 to 90, because otherwise you're firing behind you, which doesn't make any sense. So we want to put those constraints on. So that's what the angle is. So again, if I go back to the scene, let's go back to the IMGUI stuff. And I want to create another little, so we got toggle, gravity, and I also can reset everything. I also want to change my angle now. I got a new thing. M underscore angle is equal to 0.0f. I'm going to reset that, back to that. I also want to have more of these sliders, where one of them is the kicking angle. We'll call it kicking angle, where we have M underscore angle. So my kicking angle is what? So from, let's say, 0 all the way to 90 degrees. Okay? So that's going to change the angle. I also want my velocity across the x-axis and my velocity across the y-axis. And in order for me to have this, and I want to be able to change it, I need a couple of more variables. So I have my final velocity, but I want some other velocities. Let's put on some other ones. So we'll say float m underscore velocity x. That's going to be equal to 0. And float m underscore velocity y, and that's going to be equal to 0. So this is my velocity, right? Whatever the velocity is, the value. And what I want to do is I want to calculate the angle now, the object now, as opposed to what we've done before. Here's the problem. My velocity itself, this thing here, is a GLM vec2, right? I don't want this anymore. Not the same way. I want to be able to specify how much velocity on each of these based on the angle. So I want to have another value. I want to have velocity, I want to have an angle, and we're going to find out what the velocity on the x-axis and the velocity on the y-axis is. Does that make sense? How can we find that? How can I find velocity on the x or velocity on the y when I have velocity in an angle, v cos theta, v sine theta, right? Whatever the velocity is. So this is going to have to change to velocity, and this will become a float. It's not a GLM vec2, and my velocity initially is going to be 0.0f. Does this make sense? We're going to need another velocity in a second, but for now, these three things I want to change. So going back to this, and if I go back to my reset function, I'm also going to reset the velocity, m underscore velocity. I'll set that to 0, as well as velocity on the x-axis and velocity on the y-axis. I don't care right now about acceleration, not yet. Okay, cool. So kicking angle, and I want velocity, initial velocity. So this will be m underscore big velocity, m underscore velocity. And it's going to go from, let's say, 0 to, I don't know, 200. It's really fast. Okay, so we've set up everything. Now we have to change our equation. So I'm going to go back to m underscore move. Here's our equation. Well, this can't be anymore, right? Now we do have this factor. We need to include this because this is going to be critical. So we're going to say that velocity is equal to velocity times, pixels per meter. So we're going to say velocity, m underscore velocity is whatever that is times pixels per meter. We're going to convert it here, okay? However, I want to find m velocity, velocity x, and velocity y. Let's do that. So we're going to say that m underscore velocity x, right, is equal to the initial velocity, m underscore velocity, right, multiplied by cos of the angle, m underscore angle, right, multiplied by deg to rad, m underscore deg to rad, or just, I think it's just called deg to rad. Does that make sense? Yeah, it does, because this is going to be the component of our velocity on the x-axis. And the same thing goes for the y-axis. M underscore velocity across the y-axis, right, is equal to m underscore velocity multiplied by sine of m angle, whatever that is, multiplied by deg to rad. And now we have components. So now down here, we're not multiplying by velocity anymore. We're multiplying by a vector for both my velocity, right, on the x-axis and y-axis. So here we're going to say something else. We're going to put an anonymous GLM vec2 object, which we're going to put in m underscore velocity on the x-axis, and then m underscore velocity on the y-axis. And we're going to multiply that by the time. I'm just going to break these out into new lines, just so you can see everything, each term on a different line, so it makes it easier to read. All right, so again, we're starting off with the initial position, just to explain all this, right? We're taking an anonymous vector. We can name this something if you want, like final velocity or velocity vector. It'll be something that's calculated every frame anyway. So So if you really want that, we can call it something like GLM vec2. We'll call it velocity vector, which will be equal to this, just to make it simple. And then we'll multiply this velocity vector by time. Does that make sense? It's just broken down into its own little parts. So again, I've componentized the velocity. That's what I'm doing here. I've got an initial velocity. This will be like the muzzle velocity. Think of it this way. If I have a cannon, that'll be the muzzle velocity, 10 meters per second, as an example. And then I'm breaking it down, depending on the angle, right? I'm taking the angle, converting it to radians, getting a factor. This factor will be smaller than the initial velocity, whatever it is, right? Multiplying it by this to give me an x-axis component and a y-axis component. And then I'm adding it into the vector that I'm multiplying by time down here. And I'm adding it to acceleration. Makes sense? Yes? Hopefully. So this is my actual equation. This is your physics equation right here. And this is my velocity broken down. So this is my velocity. So this is like muzzle velocity. And these are my velocity components. And this is my final velocity vector. And this, you know what this is. I'll take this away. Okay? Does this make sense? Sorry? Half AT squared, yeah. So, oh yeah, so yeah, that's right. So this should be multiplied by 0.5. So let's forget to do that. Let's do that. So this is this times 0.5 times this. So I'll say times 0.5 F times this. That's correct. In fact, if you really want to be technical, then you want to do this. Just to make sure that its order of operations is preserved. Okay? And if you think about this, and if you think about we're scaling it here, we're scaling it here, we're scaling it here with time. We're doing all this scaling to make it work with our engine that we're making. Okay? Let's see if this works at all. And by the way, do we have to do anything to the angle across the y-axis? Because if you think about it, the y-axis is reversed for us. So if we have an angle that's positive going up, it's actually negative, which means we have to multiply our angle by -1. So a good example of this, our kicking angle is 0, our velocity is 0, that means we should just drop. So we should just see a drop, like normal. Okay? Let's increase our kicking angle to 17 degrees, or something like that, 20 degrees. And again, if I don't put any velocity, it should just drop. But if I put 21 degrees, by the way, the kicking angle should have been reset. When it goes back, it resets. If I change the kicking angle to 20 degrees, let's say, so kind of a low angle, it should be like something like small like this, right? If I increase my velocity, and again, I'm increasing my velocity, let's say 15 meters per second, then we should have an upward motion. But actually what we're going to get is a downward motion because y is reversed. Notice that my velocity went infinite. Why is that? That's an error, right? That's what that's showing us. How can my velocity be infinite?
Because there's no cap to the velocity itself when it's going over time.
Well, remember, I'm never multiplying my velocity by anything. Here's my velocity on the x-axis. I'm calculating by taking the velocity, the initial velocity, let's say 15, multiplied by my pixels per meter, times cos of the angle times deg to rad, right? Which means I'm converting it into radians. Now we're doing a lot here, so we got to figure out what this is. And we have to check our work. This is where calculus and physics comes in, right? So think about this, right? If I have a velocity of 10, and it's 10 pixels per meter, this becomes 20. So 20 times cos of, let's say, a 20-degree angle. So again, cos of 20, which is 0.9, multiplied by 20. What am I saying, 20? Let's go back. If my velocity is 10 and I'm multiplying it by 10, that's 100. So again, it's 10 multiplied by 10 for my scale is 100 times cos of 20. So cos of 20. There we go. Times 100. It should be 93 pixels every frame. That's what it should be. 93 pixels every frame is what it should be moving. That's the velocity. Alright? Plus any kind of downward acceleration. That's where it becomes the same. But this should not be infinite. It should be 93. The velocity across the x-axis should be 93. Does that make sense? Okay, what about the velocity across the y-axis? So again, it's 100 times sine of 20. So sine 20, 0.34, right? Multiplied by 100 is 34 pixels. 34 pixels on the y-axis, right? And then the next one is on the x-axis, right? On the x-axis, it's 93. 93 on the x, 34 on the y, right? There's more energy on the x than on the y because of the angle. Okay, that's what's happening. So that's the factor. But this shouldn't accumulate. It should never become infinite. How did it do that? What did we do to make this infinite? Well, I multiplied this velocity vector by m time, which actually makes it smaller. So where, oh where, my friends, does the x and y become 0? So one thing is the reset. Let's check the reset. Because remember, the reset function is part of the thing that we have to check to make sure it's correct. Velocity 0, angle 0, 8 times 0, right? X and Y 0. We're zeroing all this out. 9.8. So what could it be? We do it here. So that worked out. My velocity does change from 0 to whatever. Okay? But one thing we don't know is what the final angle is. So let's print that out. So as soon as I make my angle calculation the first time, and by the way, this comes back every frame, every frame, every frame. So I say, okay, fine, my velocity is so on, whatever it is, right? So down in my movement is move. I take my velocity, oh, this is the problem, right here. Look at that. That's going to happen every frame. That can't be. That's the multiplier that's happening. So I need to do this once. So not here. but rather here. So my velocity is going to be, I take my velocity and I multiply it by ppm. That's this part, right? That's like a scaled velocity. If you want to take it into another variable, you can. And then I multiply this by ppm. Because you're scaling it, right? Let's try that again. All right. Velocity. Let's go 10 or 20, 10. It's kind of hard because they're big numbers, so this doesn't do great. If you wanted it bigger, you can make this a bigger graph. So let's say 9. My velocity is 9. My kicking angle is 0. I've got my gravity at 9.8. I got my pixels per meter at 10. Let's toggle gravity off. Okay, so not much happened there. It looks like my gravity took hold and it fell at 9.1. That's about right, right? My angle was 0, which means, guess what? I'm going straight. Okay? Here's where it gets hairy. If I change my angle to like 30, what it should do is arc upwards like this. But we're not going to see that arc upwards. We're actually going to see a different arc. Let's make the same thing, so about 9, and then toggle gravity. Notice it didn't do it because of the weird angle problem that we talked about before. Remember that our coordinate frame goes up is negative, down is positive. So if I go up with my angle, which is what I'm doing, right? I have an upward angle. I need to have something where I have a negative on the sine axis, right? So times a negative angle here. I can't put negative here, but I can multiply this whole thing and make it negative, right? So I could put like negative sign, right? So whatever this is becomes, well, I can multiply the whole thing by -1, whatever you want. If I did this, and this is only across the the y-axis, not across the x-axis. And again, if I change my kicking angle to something like 30, there it is, and I made my velocity something like 20, and if I toggle gravity, you can see now I have a bit of a bump. That looks pretty good actually, right? So a bit of a bump. How about if I increase my velocity now? Let's make my velocity 100. So here's 100 meters per second. And then my kicking angle is like 45 degrees, which is the best angle, remember, for the farthest distance. Okay, 45 degrees, 100, and then toggle gravity, right? So you can see that it goes up, which mimics exactly the type of motion we want. And if this is too much, and if it went too far, right, then we can increase the amount of pixels per meter. How do I do that? How do I make it so it's tighter, a smaller scale? What do I want to do with the scale? I want to make less pixels per meter. More pixels per meter means it's going to be farther, right? Smaller pixels per meter, like 1 pixel per meter, is going to be really small. So if I went to like 1 pixel per meter, and I did the same thing, my kicking angle being 45 degrees, and then I want to do my velocity at, let's say, 100 again. There it is. Then I want to toggle my gravity. You can see that I'm going to get a different kind of scale, right? Because that's kind of what it looks like, right? Because my pixels per meter is so small. Let's go a little bit bigger. So 5, let's say. And by the way, one thing you should also do, guys, is actually try and map it. Does it make sense? You know? So kicking angle again, 45 degrees. My velocity is 100. And then try it out. Not bad. It looks fairly natural. And again, you can see that 5 pixels per meter seems to work best with our screen. So guess what? We've captured some values. Guess what I'm going to do? I'm going to use these values as my defaults. Because I know this is what I am GUI's for, guys. It's for looking and going, this looks about right. You know, for my game, it should be like this, right? If I want this kind of motion for my game, I want to kind of adjust the pixels per meter, a kicking angle, and a velocity for my jump. Let's say I'm jumping at 100 meters per second. That's Mario, right? Mario's pretty strong for his thing. It looks like the angle's right. So this is what I want. So 5, 45, and 100. So going back, I can go and reset my stuff. So again, my velocity will be 100, right? Now, careful, if I make my velocity 100 and my kicking angle 45, right? I gotta be really careful because my X and Y is going to be calculated, right? So 100, and this will be 5. I got to also reset those back to those values. So my reset's got to be back to those. So go back to reset. Again, I want my pixels per meter to be 5. Angle is 45. And my velocity is 100. All right, let's see if this works. Pretty good, right? It looks pretty good. And that means that our physics engine, the simple thing we've created right now, is working. Right? Now there's some other issues. There's things we haven't touched. For example, I have my gravity and everything else. If I want this character to be Mario, not a ship. By the way, that's the next step for us. Right? I want Mario or any other kind of character you want to jump on a platform. Right? So think about this. He's going to have some kind of angle, right? I'm giving him impulse because I'm adding force. But here we're doing kinematic motion. We're not doing Newtonian motion. Newtonian motion would be different than this. Instead of giving him a velocity, I would give him force. And I would take that force and multiply it by his mass to get the acceleration. That's a different thing than what we got here. Okay? However, I have to tell you this. For most video games, when we set up simple physics, it's like this. Once we get into force, now we're talking impulse. I'm pushing, I'm adding energy to a system, and then it's pushing something. And now I let it go and let gravity take hold. Right? That's different than what we're doing here. Questions around the stuff we've talked about today. So the importance of using an immediate mode UI and how beautiful this can be. Notice what we did here, right? For your assignment, you're going to do some kind of little simulation just like this, using this exact example that I've given you, right? But I want you to be able to map and maybe use some interesting graphics to map the what's happening. So if you're mapping R2-D2's motion as an example, he's going to be sliding down a ramp. That's kind of more difficult to do. Or R2-D2, or sorry, that's our loot crate. Or maybe you're going to be using a thermal detonator and a Wookiee's hand that throws the thermal detonator at stormtroopers. That's something you can simulate, and that's kind of the easiest one to simulate using this, right? The last one, using kind of angular force, you know, where R2-D2 is kind of going around a Ferris wheel, is the most difficult one, because you have to simulate how much force it's going to be. So questions around this, anything we've talked about today. All right, I'm going to put this up on GitHub, guys. and I will put up the video on Blackboard in a few minutes, okay? Thank you so much. Next week, remember that I'm going to be recording sessions for the physics portion, the one where we actually do some physics questions, okay? That'll be coming next week, and it'll cover last week's physics work and this week's physics work, okay? Thank you so much, guys. Take care.